Hello, everybody, and please be welcome, everyone, to this second day of AC 500 course. My name is Andres Ibarra, and today I'm going to guide you through this day two content in our module number two. So today it's going to be an exciting day. Also, remember, guys, that we are going to work into different parts during the session. The first part is going to be related with having some theory, some content of this model number two. Then we're going to have a 30 minutes lunch break or coffee break. So you can go for your favorite drink, you can go for some snack. And then the second part is going to be in order to continue with the lab activities. In this case, if you didn't have the possibility to finish your yesterday activities, your yesterday practices, don't worry, you can continue doing it along the session of today. And also we're going to have additional lab activities. So at the end of the session, I'm going to give you the list of activities that we're going to follow in the second part of the session. Also, well, I opened my camera to say hello everyone and thank you for joining us today. Remember that we're going to cover this session during 4 days. We're going to cover module 1, 2, 3, 4. So these modules were going to be during from Monday to Thursday, and on Friday we're going to have a quick summary in an exam prep session. So guys, thank you so much. It's such a pleasure to be here with you. For the moment, I'm going to stop sharing my camera, but we're going to start with today's content. So I think again, thank you for joining us, and let's start. Well, guys, just a quick reminder, a general overview of this ASAD 500 course. Remember that we are going to understand the security best practices and some of the industry security requirements, such as defense in depth. Remember that we saw previously Azure Active Directory, Azure Identity Protection, and enterprise governance. Also, we covered some labs activities, for example, the role-based access control activities, how to create Azure policies and resource manager logs. So today, we're going to continue working with perimeter security, network security, and host security. Today, we're going to be familiar with security protocols as VPNs, secure socket layers, disk and data encryption. So this is going to be related with our second day. Tomorrow, we're going to continue with data and application security. For example, we're going to mention Azure Cable, application security, storage security, and in our day number 4, we're going to talk about the Azure Monitor, some features, for example, Azure Sentinel. So, okay. Thank you for your comments, guys. Yes, in the day number 4, we're going to continue talking about the Azure Monitor, Microsoft Defender for Cloud, and Azure Sentinel. So let's start with our slides. And well, just a quick reminder, this is me. My name is Andres Ibarra. I'm an NCT. That means that I am Microsoft Certified Trainer. Also, well, I have some experience with IT projects. I used to be the IT analyst for a Mexican bank, and I worked for as a team leader for the whole implementation of IT facilities infrastructure in an aluminum can plant. And then I moved to the cloud environment. So those are some of my certs that I have. Actually, I am trying to achieve the latest one that Microsoft released in the security path. So I'm on my way to having that extra certification. Well, let's continue with our topics of today. Again, those are some of the lessons that we're going to cover. Today, we're going to cover perimeter security, network security, and host security. Those are the three lessons that we're going to cover. Container security, and you're going to look at in advance during the lab activities. So again, this is going to be related for the first part of the session. Then we're going to move to the lab activities. Let's start with our first lesson that is related with perimeter security. So it's important to start talking with some basic concepts. It's important to start having a good idea of this defense in depth strategy. So it's very straightforward, guys. You can see that it looks like an onion because it has different layers until we achieve the most important thing in our organization, that is the organization data. So you can see that we need to go through all these layers. Then we're going to get information. So this defense in depth is a strategy that employs a series of mechanisms. Again, you can see we have a start. We have a start. So this is going to be a mechanism to slow the advance of an attack that's aimed to acquire unauthorized access to information. Again, remember that this is the most important thing that we need to protect in our organization, our data, right? So each layer, it's gonna provide protection. So if one layer is breached in a certain way, the next layer is gonna be already in place to prevent further exposure. Let's make a particular mention for this physical security because, well, remember that we are working now in a cloud environment, and well, maybe some of you are no longer working physically in your main offices or in your headquarters. So in this case, the physical security it's not going to be available. It's when we present our ID, our work ID, when we are at the physical office. So we don't have any more, or well, sometimes it is not available, this first layer. So that's why our main focus moved to the next layer. So we are going to protect our identities, and also it's important to mention that we need to protect the privileged ones. For example, users with admin roles or security readers. So that's why yesterday we started talking about Azure Active Directory, Azure Identity Protection, and some features related with enterprise governance. Today we're going to continue with the next layers. So you can see right here that the next layer is going to be the perimeter, network, compute, application. So that's why this AC500 focuses these three and in these four different models. Model 1, identity and access protection. Model 2, platform protection. Model 3, that we're going to cover tomorrow, data and application security. And model 4, security operations. In this case, well, we're going to cover these ones. And it's important to mention that, well, now that I know which layers I'm going to cover during this module, number 2, now which are going to be the services that I'm going to have available from Azure to protect my organization. In this case, we're going to have some features like DDoS protection. So Azure is going to protect us within these different these kind of attacks. We're going to cover it in the next slides. Also, we're going to work with Azure Firewall components and one similar component with Azure Network Security Groups. So together they are going to provide a robust or strong defensive network security. And well, just to mention, Azure Firewall, it's a fully stateful, centralized network firewall as a service that Azure provides. we can combine these features, for example, with web application firewall that is going to be focused to protect the access of the applications, and application gateway that is going to be a load balancer. So combining these web application firewall with the Azure firewall with the application gateway, we are going to get inbound protection, outward protection, and app protection, right? So let's continue. Well, it's important to say that the last layers, we are going to protect it with security for, in this case, container security. We're going to use also one feature called Azure Information Protection, but today we're going to focus in this middle part. Let's continue. Well, so you can see right here what is the difference between what we used to work. For example, the user used to be right here at the main offices, and now it's using a cloud environment. So using this cloud environment allows the user to access to cloud resources and also connect with their enterprise or their organization and access to those resources on-premise too. So it's important to, when we are going to access to these resources, it could be through a physical device or a virtual device, for example, a virtual machine. It's important to connect it to an Azure virtual network. So a virtual network is going to be, guys, a logical construct built on the top. You can see right here that you are going to face this one first. A virtual network is going to be that logical construct built on the top of the physical Azure network fabric, and each virtual network is going to be isolated from all other virtual networks. For example, we can separate the production virtual network and the administrator virtual network, or for example, the security virtual network for security devices. So we can manage different virtual networks in order to protect these, or protect or isolate these from another network traffic, right? So you don't need to be worried about this, because maybe you work with this on your existing on-premise infrastructure. So you can start thinking in some of these concepts. For example, what does a network look like on-premise? How do we secure the traffic coming into our network? How do we separate our applications? And in this case, if you are working with an IT team that it's focused to develop applications, and then we have another team to test, how do we separate these activities from the production? So it's important to keep it separated, because you can create conflict, or you can make changes that affect the other areas. Another question that we can think is, well, in this case, how do we protect internet-facing applications? That's why we have the web application firewall. We are going to find it in the documentation as a web application firewall. In case to be attacked by a bad actor, in this case, how do we protect our organization from these DDoS attacks? So automatically Azure is going to offer us this DDoS protection, and well, we're going to have different tiers according to the protection that we require. Also, well, we can continue thinking in some different questions, and we're going to discover which feature is going to help us with all this during today's session. For example, the last questions that we can think about is how do we manage the ENS and how do we balance our traffic between multiple servers, right? So that's why we're going to work with virtual networks and add this security layer. So let's start talking about these attacks that a bad actor can place in our organization. So those attacks are generally called distributed denial of service or DDoS attacks, right? And you can see right here one example. So the main goal is to flood all the internet connections that goes to our organization and make unavailable the network services. So you can see that we have illegitimate connections to our application servers, or maybe to one feature that we provide in our organization. So the main goal is a denial of service attack. It's an attack that again prevents access to the service systems. If the attack originates from one single location, for example, let's think that we only have this place that where the attack started, it is going to be only called DOS protection. But nowadays they are using a lot of different devices from different parts of the world and flooding the internet connection, trying to prevent the legitimate access to our main systems. So that's why we are focusing in this DDoS protection. So again, DDoS protection, DDoS is a collection of attacks that aim at disrupting the availability of a target. Sometimes it could be a person, or some other times they use botnets again to start these kind of attacks from different parts and also in the same time. Again, it's going to flood the internet traffic. So in this case, how do we protect our organization against this kind of attacks? Well, for that we have Azure DDoS protection. So Azure DDoS protection, we can combine against, we can use it to prevent this kind of attacks, and we can combine it with another Azure features. Also, well, it is important to mention that some of the features that Azure offers, those are presented in different tiers according to the subscription that you have in your organization. For example, we can mention that we have a basic one and the standard one. So those are the two different available tiers that Azure offers this DDoS protection. For example, the basic one, this service tier, it's automatically enabled as part of the Azure platform. In other words, by default, we have this one. But, well, this is going to include always-on traffic monitoring and real-time mitigation of a common level attacks. Also, this is going to provide the same defenses that Microsoft online services already use. So that's why we have already this basic one. In the other hand, well, we have the standard tier. So this standard tier, this service is going to provide additional mitigation capabilities over the basic service So these are tuned specifically to Azure Virtual Network Resources. So this DDoS protection in the standard version, well, it's simple to enable and it doesn't require change anything in our application. We're going to be able to implement policies, well, protection policies that are going to be tuned specifically to monitor the traffic, and also it's going to use machine learning. So that's why we need to be aware of this kind of DDoS attacks, but also we need to be sure that Azure already protects us with these two different tiers of DDoS protection. In the same way, well, we have Azure Firewall. So Azure Firewall is going to be another additional feature that Microsoft offers us. And you can see in these diagrams that, well, as well, in the same way that we have DDoS protection in a basic, in two different tiers, well, we have two different tiers for the Azure Firewall. In this case, we have the standard version and the premium version. What is this Azure Firewall? Well, let's start from the top and say that Azure Firewall, it's a cloud-native and intelligent network firewall security service. And these guys, it's going to provide the best of the breed threat protection for our cloud workloads running in Azure. So again, the main difference between these two tiers, we're going to have a standard version and a more complete version. That's Azure Firewall Standard. It's going to provide filtering and threat intelligence feeds directly from, well, all the experience that Microsoft has as a cybersecurity organization. So it's going to provide threat intelligence-based filtering that can alert and deny traffic from or to non-malicious IP addresses, and also domains which are updated, all these in real time, to protect the new and emerging attacks. In the other hand, well, the premium tier, Azure Firewall Premium, is going to provide these advanced capabilities. So it's going to include signature-based IDPs, and these guys, it's going to be to allow a rapid detection of attacks, all this by looking for a specific patterns. So these patterns can include byte sequences in network traffic, or also non-malicious instruction sequences used by malware or attackers, right? So some examples, well, it could be the use of malware, some phishing attacks, coin mining, and Trojan attacks. So we can choose this Azure Firewall. We're going to use it with an Azure Firewall Manager, and this is going to be our central point to manage all the Azure firewall across multiple subscriptions. The Firewall Manager is going to leverage firewall policy to apply a common set of network or application rules and configuration to the firewalls in our tenant. And again, this is offered in two different tiers. So you can see an example that this is how the Azure Firewall works. We have a global admin. Remember that it's important to assign the least privilege possible. So the global admin is going to be in charge to start deploying these features. And then we have the Azure Firewall that is going to be that central security policy and route management. So one of the benefits using this Azure Firewall Manager, it's that we have a secure virtual hub. This Azure Virtual Hub, it's a Microsoft managed resource that let us easily create a hub and spoke architectures. So when a routing policies are going to be associated with such hub, this is going to be referred as secure virtual hub. You can see right here. Then you can see that we can assign uh, a little bit, well, different roles that are going to be not necessarily the global admin one, but we can delegate activities and permissions using different built-in roles, or we can create custom roles if we have the appropriate license. For example, license premium P1 or P2 license, we can create these custom roles. So again, the main idea is to delegate, but give just enough privilege and just in time. Let's well, just to continue mentioning this Azure Virtual Hub. This is a standard Azure Virtual Network that we create and manage ourselves. So when our security policies are associated with such hub, it's referred to as a hub virtual network. So we can peer-spoke virtual networks that contain our workload servers and services, and we can also manage firewalls in standalone virtual networks that aren't peered up to any spoke yet. So yes, you can see right here that we have this hub and we are connected all our workloads. So well, in this case, this is important, guys. This is how we implement the ability to control routing behavior on our virtual network. And remember, guys, that always is going to be an important task or a critical task, right? We're going to prevent the connections outside, or also where you can restrict connections inside our organization. So if this routing is configured incorrectly, the applications and services host in our virtual machine might connect to unauthorized devices. This includes system owned and also operated by potential attackers. They can get, again, we need to protect our data. That is one of the most important things that we have in our organization. But if those attackers are already inside of our organization, it is going to be very easily for them to extract or get this information. For that, we're going to talk about, well, an additional tool to validate that these connections are going to be automatically redirected. So we have a feature that is going to be called Azure Firewall Force Tunneling. So this force tunneling is a mechanism that we can use to ensure that our services are not allowed to initiate a connection to devices on the internet. When we configure a new Azure Firewall, we can route all these internet-bound traffic to a designated next hop instead of going directly to the internet. So this is a very useful thing right here because we are going to be evaluate these internet connections. For example, we may have an on-premise edge firewall or another network virtual appliance. All these, it could be to process the network traffic before it's passed on the internet. But however, we can't configure an existing firewall or also a force tunneling. So that's why we have this additional benefit against maybe some on-premise devices, right? So this force tunneling let us redirect, or in this case, as the name says, well, we're going to force this all internet bound traffic back to our on-premise location. In this case, it's going to be via a site-to-site VPN tunnel. And again, we're going to be able to inspect and audit all these connections. So without forced tunneling, this internet-bound traffic from our virtual machines, for example, in Azure, always are going to traverse from Azure network infrastructure directly out to the internet. So this is going to be without the option to allow us to monitor, inspect, or audit this traffic. You can see it right here. So we are mitigating these external internet connections, and now we are redirecting this to our evaluation and audit process. For example, in the example of this slide, the front-end subnet, you can see right here, this front-end. Here we go. This front-end subnet doesn't use force tunneling, so this means that it can connect directly to the internet. The workloads in the front-end subnet can continue to accept and respond to customer requests that come directly from the internet. There you can see that we have no restrictions right here. Then the mid-tier, and in this case, the backend, they are not doing the same because we are mitigating these kind of connections. And now, any outbound connection from these two subnets to the internet are going to be forced back to an on-premise site via these VPN tunnels, right? So we are going to be, again, able to inspect it and audit these connections. Another benefit that, well, we can use using these perimeter security features and network security features, well, we can use user-defined routes. You can, in the official documentation, find it as UDRs. So in this architecture, the NBA is going to provide a secure network boundary by checking all the inbound and outbound network traffic, and it's going to pass only the traffic that meets network security rules. So, however, the fact that all network traffic must pass through these NVAs is going to mean that, again, this NVA, it's a single point of failure on the network. So, if the NVA at some moment or at some point it could fail or it could be down, there is not going to be any other path for network traffic, and all the backend subnets are going to be unavailable. So again, it's important to mention these tools, guys. We're taking back this hub and this spoke technology with Azure. So the architecture is going to consider and consist with some of these components. For example, you can see right here that you have your on-premise network with your virtual machines and load balancers and gateways. First, you can see that we have a VPN device. So a device a device or service that it's going to provide an external connectivity on the external network is going to be through these VPN connections. Then the VPN device may be a hardware device or a software solution. So we can see from Azure that we can allow these VPNs connections and automatically gets to this hub. And we mentioned that this hub, it's the central point of connectivity of your on-premise network and a place to host services that can be consumed by different workloads hosted in the spoke virtual networks. So they are not getting directly to our resources. They need to face this network hub, and then we can filter these connections with the Azure Firewall or directly with the VPN gateway. We can monitor these internet connections, and finally, we can get through our required devices or services on the cloud environment. In the other hand, well, what happens if we want to connect to a virtual machine directly without, for example, from an external device or a computer? We can log in into the Azure portal and start using Azure Bastion. So again, we're getting all connections are getting in this Azure Virtual Hub. Azure is gonna process in a secure way these external connections from our external devices, and then it's gonna connect directly and allow us to have a secure connection to our specific virtual machine, required this virtual machine, for example. So you can see that we are adding additional points to connection between inside, outside our organization, or also inside our organization. For example, we are going to protect internal connections using these network security groups, right? So we can start implementing rules for internal connections between our resources. With that, guys, well, we're finishing our first lesson of today that it was related with perimeter security. So we are going to talk about network security now. Previously, we saw right here some additional components, for example, the Azure Bastion, the network security groups, and well, in this case, we're going to cover this network security part in this new lesson. So let's start with these network security groups. It is important to mention that sometimes these network security groups could be confusing or could be confused with a firewall. But well, one key point right here is that we're going to use directly these network security groups to help connect our resources inside our cloud environment. So this is going to be part of, or the key point of using these network security groups. And the firewall is going to make directly face to external internet connections. So this is focused again for internal resources. So again, well, let's start from the scratch and ask, well, again, what is a network security group? A network security group contains security rules that allow or deny inbound network traffic to or outbound connection traffic from several types of Azure resources. So talking about security rules, network security group contains 0 or as many required rules For example, if your organization needs to filter in at different levels all the internet connections, well, we can have from zero to many desired rules. So each rule needs to have specific properties. For example, we need to assign a name, we need to assign a priority. So it is the larger the number of the priority, it's going to be less. It's going to be evaluated at the end. So the closer number to zero, we have this associated rule. Well, the higher priority it's going to have in our organization. Also, we need to define, well, the source or destination in these properties when we define these network security groups. Remember, guys, that we are working with network, so it is important to define the protocol, the direction, and also, if it is necessary, we can define the port range, because maybe you are closing for security, for your security posture, you are closing this large range of ports, so you can define which ports are going to be available to allow connections. And well, finally, the action that we're going to take if we're going to allow or deny these connections. In other words, guys, you can use Azure Network Security Groups to filter network traffic to and from, again, the Azure resources in an Azure virtual network. So just as simple as that. Then it's time to mention this, well, this network security groups implementation. We already know that our devices, it could be a tablet, a laptop, it could be a mobile phone. Well, we have these internet connections, hardware pieces. In this case, these how could I say that? Well, we have these network interfaces. It could be wireless. It could be completely by Ethernet cables, or also fiber optic. But what happened when we are working with virtual devices? So we are going to have also network interface for those virtual devices. In this case, it is going to be important to know this, because to simplify the management of these security rules, it's recommended that we associate our network security groups to individual subnets. And well, in this case, it's going to be better rather than individual network interface within a specific subnet. So these security rules in the network security groups enable us to filter network traffic that can flow in and out of our virtual network subnets, and also over these network interfaces. We have some default security rules that are provided with these network security groups. So we cannot delete these default rules. But in other hand, well, if we cannot delete these default rules, we can add additional rules and add a higher priority to be evaluated. So then we can configure and set the rules according to our security posture of our company or organization. Right, guys? In the other hand, well, what happened when we are working directly with applications? We have application security groups in a similar way that network security groups. So the application security groups enable us to configure network security as a network extension of an application structure. And these guys is going to allowing us to group virtual machines and define the network security policies based on those groups, right? So, for example, making a small summary, the application security group, along with the, let me go back a moment. Remember these network security groups. You can see right here is network interface. Okay, here we go. Again, the application security group with these network security groups, you can see right here, like we have a network security group, network security group. This is going to bring several benefits in our security. For example, we are going to have a single management experience. We are going to be able to increase the limits on multiple dimensions. We're going to have a great level of simplification. And well, this is going to be a seamless integration with our architecture. So we can get different benefits. And you can see that we can wrap that application security groups with network security groups for additional security. So the main goal is to prevent inside or also outside communications. Now, guys, it's time to talk about service endpoints, virtual network service endpoints. Let's start saying, well, what is this service endpoint? The virtual network service endpoint, it's going to provide secure and direct connectivity to Azure services over an optimized route over the Azure backbone network, right? So you can see right here that once that we have a connection directly to Azure resources, it's going to be very easily to determine where we're going to move or what we can do with these connections. But for on-premise services, we can use this ExpressRoute public peering on an internet access through the NAT IPs. So these endpoints allow us to secure our critical service resources only in our virtual networks. This service endpoints enables a private IP address in the virtual network to reach the endpoint of an Azure service without needing a public IP address on the virtual network. So again, we are going to extend this private connection, and this is going to be completely more secure. We have several key benefits, for example, improved security for our Azure service resources. We're going to be able to create an optimal routing from Azure service traffic from our virtual network, and it is going to be very simple to set up with less management overhead, right? Let's continue talking about these endpoints. So again, taking back this private endpoint, Azure Private Endpoint, it's a network interface that connects us privately and securely to a service powered by Azure Private Leaf. How does it work? Well, in this case, these private endpoints, it's going to use a private IP address from our virtual network Well, this is going to be very effective, bringing the service into our virtual net. So in this case, you can see right here, again, we have external connections from our organizations. We are getting to these balancers, service, firewall services, and we're going to use network security groups uh, to get this private endpoint. So we're going to be able to generate a private link to connect directly to a specific service. So what we can do with this private Azure private endpoint, well, in this case, the services could be an Azure service such as Azure Storage, Azure Cosmos Database, Azure SQL. What we can do in this case, we can private endpoint in a certain way enables the connectivity between the customers from the same virtual net, regionally peer virtual networks, globally peer VNets, and also on-premise using VPN or ExpressRoute connections. And well, this is going to be served by this private link. The network connections can only be initiated by clients connecting on the private endpoint. So the service providers do not have any routing configuration to initiate connections into service customers. And the connections can be only established in just a single direction. You can see that we don't have any outside connection. When we create a private endpoint, a read-only network interface is also going to be created for this life cycle of the resource. So the interface is assigned dynamically. It's going to get a dynamic IP. So dynamically, it's going to be assigned to a private IP. And well, this is going to be from the subnet that maps to the private link resource. The value of the private IP address remains unchanged for the entire lifecycle of the private endpoint. It's going to keep that private IP address. And we can mention that the private endpoint must be deployed in the same region and the subscription as a virtual network. So it is important to take this consideration when we are creating these private endpoint connections, right? What happens if we have, well, a lot of connections and we need a way to manage and distribute all these external connections that came to our virtual network? Well, Azure offers us this Azure load balancer. In this case, this load balancer, you can see right here, that we are getting these external connections, and well, it's going to separate all these connections. So the Azure load balancer operates at the layer 4 of the OC model, and it's going to be this single point of contact for clients. Then the load balancer, it's going to distribute again inbound flows to arrive at the load balancer's front end to backend pool instances. You can see that we have a public base load balancer, and also we can establish an internal load balancer. So we have two types of balancers. In this case, I already mentioned it. It's going to be a public one, and well, we're going to have an internal one. A public load balancer can provide outbound connections from our virtual machines inside our virtual network. These connections are accomplished by translating their private IP address to a public address. These public load balancers are used to load and balance internet traffic to our virtual machines. You can see that at this point is distributing these external connections. But again, this is going to be a public place. On the other hand, what would happen if we need to make do it privately? We have an internal or private load balancer. So this is going to be used where private IP address are needed for the front end only. So this internal load balancer are used to load balance traffic inside our virtual network. You can see that right here. In this example, we are already in our virtual network. But if we need to balance internal connections, well, we establish this internal load balancer. And again, it's going to help us to distribute these workloads. Why use this kind of technologies or features from Azure? What happens if you need to scale your applications at a certain point? If you have a public place application, but it is getting more and more connections, well, using these load balancers, we are going to create highly available services. Also, the load balancer supports both, you can say in this way, inbound and outbound scenarios, and provides low latency and high output. And it could, well, it can scale up to millions to flows to from TCP or UDP applications. Now, we already talked about this load balancer, but in the other hand, we have an Azure application gateway. So this is important to understand these guys because all these products should work together to provide an optimal protection. So an application gateway is going to be a web traffic load balancer that enables us to manage traffic, but this is going to be related for our web applications as the name said. The key point right here is that applications. Remember, the traditional load balancers operate at the transport layer, or in this case, the layer 4. And well, route the traffic based on source IP address and port to a destination IP address and port. But on the other hand, the application gateway can make routing decisions, and all these based on additional attributes for an HTTP request. For example, a specific URL path or host headers. So you can see that our users are going to paste this application gateway, and then the application gateway is going to take control how to distribute these connections. The application security, a very good option is to strengthen these connections and security using also the web application firewall. So this is going to be for balancing the connections But the web application firewall, it's going to implement the rules of connections for, again, our applications. The combination of these two features, well, it's going to provide an amazing protection to our applications against common vulnerabilities. And, well, it is going to provide an easy to configure central location to manage it. So previously we mentioned this web application firewall. So it's time to go a little bit deeper right here. You can see that, well, that's why we talk about DDoS attacks and attacks from bad actors outside our organization. Some of these attacks could be cross-site scripting, or maybe for your application, they are going to try to use SQL injection. So when you have an application and you want to protect these kinds of bad actions, you can implement this web application firewall. So you can see that right here that we are detecting bots, bad actors, or external services, and we are going to allow legitimate connections from our external clients. So this web application firewall provides centralized protection for your web applications from common exploits and vulnerabilities. The web applications, well, in this case, we are taking back this part that we work inside, but now also outside our organization, maybe at home office, or we need to travel a lot. So at the end, we need to use applications maybe to continue our workloads, our activities. So that we are increasing the amount of applications that we are consuming, and also this means that the attackers are increasing the amount of bad actions trying to vulnerate these applications. So they can start using, again, this SQL injection and cross-site scripting. Those are some of the most common attacks. We have many others, but, well, at the end, if we increase the use of applications, those kinds of attacks also are going to increase. So all the web application firewall features exist inside a web application firewall policy. Remember, just to keep in mind, remember policy, it's going to be equal as rules. So we're going to use, we can create multiple policies or rules, and they can be associated with an application gateway to individual listeners or to path-based routing rules on an application gateway. That is some of the benefits that we have. And also, if we want to work with Azure Front Door, that is going to be allow us to connect from services that are not, well, maybe implemented in a certain way far away of our organization. We're going to be able to use this web application firewall with Azure Front Door to have access in a more easy way to those applications that, well, again, in a certain way, we mentioned that it could be far away of our physical locations. Talking about Azure Front Door, well, you can see right here, one way to protect an Azure service is to make it high available, very responsive, and also well, it is not only important to increase the services, it is important to monitor. In this case, we can monitor its performance or responsiveness. So that's why we want to use this Azure Front Door service. Let's take it from the top and mention, well, what is this Azure Front Door? Uh, Azure Front Door is going to enable us to define, manage, and monitor the global routing from our web traffic. All this by optimizing best performance and instant global failover for high availability. With this Azure Front Door feature, we can transform our multiple region, consumer, and enterprise application into robust, high performance, and personalized modern application APIs and content that reaches a global audience with Azure. Again, that's why we mentioned that I mentioned previously that in a certain way we are going to have secure and easy access to applications that are maybe far away from us. So this is going to work at the layer 7, or well, in this case at the HTTP or HTTPS layer. And it's going to use any cast protocol with split TCP and Microsoft Global Network for improving global connectivity. Based on our routing method selection in the configuration, we can ensure that this Azure Front Door is routing our client request to the fastest and most available application backend. So remember, this application backend is the internet-facing service host inside or also inside Azure. And again, so we can see that this is working at the level at the layer 7. We're going to be able to split the TCP protocols. We can support URL-based routing, multi-host siting, multi-site hosting, custom domains, and certificate management, because it's important to validate these protocols. We can use, again, in combination with web application firewall. And well, we can manage URL redirection and URL rewrite. These kind of protocols support IP in their version number 6 connections. So at the end, we are making these applications easy to get to our final customer. Another way to make an easy access to our resources, for example, you can see right here, SQL databases, virtual machines, and other services provided by Azure, or also services provided by Office 365 or Dynamics 365. Well, it's by the use of these ExpressRoute connections. And this is very straightforward, guys, because, well, the diagram is very friendly. You can see connections focused to go to Microsoft Bing for Office 365, Dynamics 365, Azure Public Services, or resources inside our virtual network. So this is, for example, it is similar when we want to go to the roller coaster and we buy a VIP pass and we skip that large queue to access to the roller coaster. So this is going to be in a similar way. This ExpressRoute it lets us extend our on-premise network into the Microsoft Cloud over a private connection with the help of connectivity provider. So with ExpressRoute, we can establish connections to Microsoft Cloud services such as Microsoft Azure and Microsoft 365 products. This kind of connectivity can be from any to any IPVPN network, a point-to-point Ethernet network, or also a virtual cross-connection through a connectivity provider at a location facility. So again, with these ExpressRoute connections, we don't go over the public internet. Again, as the previous example, we are hiding a VIP pass to access directly. This allows ExpressRoute connections to offer more reliability, faster speeds, consistent latencies, and higher security than a typical connection over the internet. It's important to mention that, well, in the context of ExpressRoute, the Microsoft Edge is going to describe the edge routers on the Microsoft side of the ExpressRoute circuit. So this is the ExpressRoute circuit point of entry into Microsoft network, right? And again, once that we start implementing this kind of connections, well, we're going to have several key benefits. For example, remember, guys, that Microsoft works all around the world. So we are going to have this connectivity to Microsoft Cloud services across all regions in the geopolitical vision. We have this global connectivity to Microsoft services across, again, all regions with the ExpressRoute. And also, well, we have it in different versions. For example, for this global connectivity, we are going to use ExpressRoute in the premium add-on. We are going to be able to have dynamic routing between our network and Microsoft via border gateway protocol. This is going to be built in redundancy in every peering location for higher reliability. And, well, in this case, we have many other key benefits using these ExpressRoute connections. In this case, also, we can, well, this is going to be offered in different versions or tiers, and we can purchase ExpressRoute circuits for a wide range of bandwidths. For example, we can start from 50 megabytes per second, 100 megabytes per second. We can scale it up to 1 gigabyte per second. And the top of the internet connection could be 10 gigabytes per second. So this is important to keep in mind because, well, according to the tier that we buy or the add-on that we buy, is going to be the connectivity available. So you can see, well, in this case, this ExpressRoute service provider model. Again, we can extend to a cloud exchange location, a point-to-point Ethernet connection, or any-to-any connection. Again, we're going to use these ExpressRoute connections to have these key benefits. For example, if it is located at the cloud exchange, in this case, with Cloud Exchange, we can order virtual cross connections to Microsoft through the
the colocation provider's Ethernet exchange. This colocation provides, in this case, we're going to use a provider, and this offer either layer 2 cross connections or managed layer cross connections between our infrastructure in the co-location facility at the Microsoft Cloud. Also, we have point-to-point Ethernet connections, so we can connect our on-premise data centers or also offices to the Microsoft Cloud through the point-to-point Ethernet links. These point-to-point Ethernet providers can offer layer 2 connections, or again, in the same way, manage layer 3 connections between our site and the Microsoft Cloud. And well, the third different service provider model is going to be any-to-any, so we can integrate our one connections with the Microsoft Cloud. In this case, it depends of the provider how it's going to be the service available, right? But again, we're going to use ExpressRoute that allows us to use Microsoft, part of the Microsoft infrastructure. Or in the other hand, we have ExpressRoute in the direct version. So this is going to be, in a certain way, a dedicated service. ExpressRoute Direct gives us the ability to connect directly into Microsoft Global Network at premium locations strategically distributed around the world. So this ExpressRoute Direct provides also dual 100 gigabytes or 10 gigabytes connectivity, which supports active-to-active connectivity at scale. So we can work with any service provider or the ExpressRoute Direct. Again, for every of each features, we're going to have key benefits. So, for example, we're going to have this massive data ingestion into services like storage and Cosmos DB database. We're going to be able to provide it. Physical isolation for industries that are regulated and require dedicated and isolated connectivity. For example, let's think in a bank or government and also the retailers. And we're going to have as a key feature, well, granular control of circuit distribution based on business units, right? So this is going to be the direct model versus the service provider model. Just for summary, well, you can see the ExpressRoute using the service provider versus the ExpressRoute Direct. You can see that, well, we can increase the speeds available. In this case, we can start from a basic connection up to the most optimized connection. You can see the difference. So ExpressRoute Direct gives us the ability to connect directly into, again, Microsoft Global Network at peering location, strategically distributed around the world. These are, again, the circuit SKUs that we have available for this ExpressRoute. So it is important to mention, well, the physical ports, again, guys, is going to pair 100 gigabytes per second, or we can establish this 10 gigabytes per second only. And if we need to secure it, we can establish multiple virtual circuits. With this, guys, we are finishing our second lesson of today, and we are reaching our third lesson that is related with host security. Just a small pause, and it's important to mention, guys, that, well, once that we finish this first part of today's session, we're going to have a 30 minutes break, and then we're going to move to the lab environment. So you can continue practicing, but now with these new features that we saw in this day number 2. Some of the practices that we're going to cover today are going to be the use of network security groups and application security groups, how to deploy and implement an Azure Firewall, and configuring and securing, well, in this case, this is going to be additional from the content of what we saw today, because this is going to be related with container security, but it's very straightforward. Configuring and securing Azure Kubernetes services. But, well, the important thing is that we are going to use this model number 2 to protect, to offer platform protection. So let's continue with this host security. And, well, in this case, endpoint protection. Let's start saying what is an endpoint. Remember, guys, that computer systems that interact directly with users, all these are going to be considered as endpoints. For example, a mobile device, a tablet, a smartphone, a laptop. So systems on devices such as these previously mentioned laptops, smartphones, tablets, and computers all need to be secure to help prevent them from acting as gateways for security attacks on organization network systems. So earlier in this module, we discussed the shared responsibilities of helping secure services in Azure. For example, Internet infrastructure as a service involves more customer responsibility than platform as a service, and also than software as a service. So Microsoft Defender for Cloud is going to be a very useful tool, and this is going to provide what we need to harden our network, help secure our services, and stay on the top of our security posture. So, well, let's start mentioning this endpoint protection. Let's have a quick overview of this. Microsoft Defender for Endpoint is going to be, in a certain way, an holistic, cloud-delivered, and endpoint security solution. In other words, it protects our Windows and Linux machines where they are hosted in Azure, or also we can use these features to protect our hybrid environments if we are going to create a relation between our on-premise services and cloud services. Also, we can extend this protection to AWS. So we have some of the main features that are risk-based vulnerability management and assessment. We are going to be sure that we're going to reduce the attack surface. Also, we're going to monitor the behavioral of our devices. So this is going to be a behavioral-based and cloud-powered protection. We're going to have a EDR feature, that means endpoint detection and response. We can implement automatic investigation and also remediation. And finally, as key point, we can mention that we can start managing hunting services. So we have a first step to use it and help protect against malware. It is important to install anti-malware to help identify and remove virus, spyware, and other malicious software. For that, we can install a Microsoft anti-malware or an endpoint protection solution from a Microsoft partner. Next, we are going to integrate our anti-malware solution. We can involve it or integrate it with Microsoft Defender for Cloud. And all this is going to be helpful to monitor the status of this anti-malware protection. So we have the security center, and this security center is going to report, it's going to provide the report on these endpoint protection issues. Security center also is going to highlight issues such as detected threats and insufficient protection of our endpoints, which might make our virtual machines or devices, such as computers, could be vulnerable to malware threats. So by using information on endpoint protection issues, we can start making a plan to address and identify these issues. Again, that's why we are mentioning that we need to protect our devices against this anti-malware. It's important to install an endpoint protection solution or use the security center. Also use a security center, sorry. In this case, we have, by default, one security software that Microsoft offers with their operating systems. In this case is Microsoft Defender. But we can start protecting our devices, extending this protection with Defender for Cloud. Now, well, another things that we can start implementing to protect our devices, well, in this case, it's important to know that we can use hardware protection. For example, BitLocker to cipher our data. In certain machines, we're going to be able to use BitLocker, the private encryption. Also, well, we can start implementing secure boot of our operating system according to the device capabilities. It is important to update always our drivers, firmware in our computer. We have this tool called the Trusted Platform. So this is going to be this TPN module is going to help us to secure our identity, our credentials inside a module indeed or around the main processor of our device. So this is going to be stored only in the device. This is not going to go over the network. And well, it is going to be as part of the hardware of that device. It is not going to be possible to access directly. So it is going to store automatically the authentication process of accessing to an operating system. Well, we have many other features. For example, we mentioned previously this passwordless authentication related with Windows Hello, and we have the version of Windows Hello for Business. What happened right here? This guidance is part of the complete privileged access strategy, and this is implemented as part of the privileged access deployment. So we have several articles provided by Microsoft that allows to what are going to be the best practices to protect and deliver security to our end users. So again, we are going to establish this strategy for the privileged access, especially for those users that have admin roles or administrative tasks and access through the use of their devices. In the same way, well, we have privileged access to our workstations. So we recommend using these privileged access workstations and VPN connections when we are administering Azure virtual machines in Azure. So this is going to be presented in the official documentation as PAW. So these privileged access workstations provide a dedicated operating system for sensitive tasks with additional protection from internet attacks and threat vectors. We can use this privileged access workstation that is going to use a security enhanced management workstation to help protect sensitive accounts, tasks, and data. Also, this reduces the attack surface of the workstations, and these security enhanced management workstations can help us mitigate some of these attacks and make all the data safer. Also, we can enforce security policies across all our devices that are used to consume data regardless of where is the data located, for example, in the cloud or on-premise. What happens if we want to work with, well, virtual machines and we want to protect and create specific machines for our, we want to create a template to create a specific virtual machines with our requirements. In this case, we can start using REM templates. So these virtual machine templates are going to allow us to, again, if we know that we need to protect our endpoint devices, when we create a specific template, this is going to improve consistency. This is going to be very helpful to deploy easier and faster virtual machines, reduce manual tasks, and reduce the possibility of errors. We can choose, we can modify these templates to improve it, and we can reuse it in case to replicate, to need to replicate these configurations many times. This could be modular, can be linked. If we want to orchestrate a whole deployment, well, it is going to be very helpful to simplify the process. And again, the important thing right here is that we are going to enforce security concerns. So we can start using a JSON file, and we are going to start using these ARM templates, Azure Resource Manager templates. So for that, we're going to use the Resource Manager, and this is the deployment and management service for our Azure subscription. So we can start using the Resource Manager with this template and using Azure PowerShell, Azure CLI, REST APIs, or client SDKs. The Resource Manager API it's going to handle this request. So, for example, some additional consideration using these ARM templates are going to be, for example, the resource provider. So this is in this part we're going to specify as that service that it's going to be supplied by Azure resources. For example, we can, in this file and in this section, we're going to specify if we want to create a compute, a storage account. In this particular case, for the virtual machines, we're going to specify it as Microsoft.compute. So these templates are going to indicate that as a resource, it's going to create a virtual machine. And also we can specify the characteristic of that virtual machine. For example, the amount of storage, the amount of RAM, the amount of the kind of the processor that we're going to assign to this virtual machine. And well, if we need to, again, duplicate this activity, we can reuse this template as many times as we require. Again, this is going to enforce security concerns, and we can do fine-tuning to keep improving these deployments. Another way to protect our endpoint, well, in this case, it's through remote access management. So we have three different ways to protect this remote access. For example, we have remote desktop protocol. So in this case, this is going to be for the access to Windows virtual machines. What happens if I have a virtual machine that is going to run on Linux? Well, I can establish secure shell protocol. This is going to be for Linux machines. But what is the difference right here? Well, in this case, I'm going to make the request through access to these machines, and I need to open ports inside my virtual network. So if I start opening these ports in my virtual network, this could be a risky situation.
Hello, folks. How are you? This is David. Good morning to everyone. Let's wait a couple of minutes just to see if Andres can come back with us. So please be patient with us. We'll be back really soon. Thank you.
Good morning, guys. As you can see, I face issue with my main computer. Fortunately, I have one additional device. I don't know if you can hear me. Okay, here we go. So, guys, I really apologize about this. I don't know what happened with the main computer, but let me take back from this side. I'm going to start sharing the course that we were mentioning and the topics that we were mentioning previously. So please, thank you for bearing with me. I'm going to start sharing my screen just in a couple of minutes. We're almost reaching the end of the session, don't worry. So we were working with, remember we were mentioning this virtual machine remote access. Unfortunately, well, I'm going to do my best to repeat it. So give me just a second to be prepared. Again, I really apologize about the inconvenience of this, but I am almost ready to take it back. I'm just going to start sharing my screen. Here we go. Okay, guys, I am going to just ask for 1 more minute to connect my audio system to you in order that you can hear me in a better way. So please bear with me. For the moment, I'm going to just close my camera. That's you're going to see all the connections. So again, thank you so much for bearing with me. The computer is acting on a little bit. Please give me 1 more minute. Thank you so much. Okay, guys, I'm going to do a small audio test. So you should be able to hear me loud and clear. Great, guys. Well, let's continue our session. And thanks again for bearing with me and be patient with this abnormal situation. Okay, we were mentioning about this remote access management. So let me take it from the top. Again, we're going to secure the way we connect to our virtual machines. Let me just take my pen. If we want to protect the connection for our Windows devices, we are going to use these RDP connections. Also, we are going to be able to manage it for Linux, if our servers are running on Linux, so we can access directly requesting the access to the virtual machine, and we can use just-in-time access. So with just-in-time access, we can establish a time boundary where the connection ports are going to be available. Once this time period finish, automatically Azure is going to close these ports. So we are not going to be able to connect anymore. But in this way, we're going to secure the way that we connect to our remote access devices. On the other hand, I was mentioning that we can use the Azure portal, and Azure provides us the most secure way to connect to these remote devices or remote virtual machines through the use of Azure Bastion. So in this case, we are not opening any additional ports to connect to the virtual machines. We are just logging in to the Azure portal. Then we're going to select the required virtual machine. Azure Bastion is going to take care for this management of connection, and it's going to provide a secure communication with our servers or virtual machines, right? With that in mind, well, let's move to the next slide. So what happened right here, guys, in a very short way, we have the update management. The update management, this is going to be a very straightforward part. You can see right here. It's going to allow us to make updates for our operating system from Linux or Windows. All these in machines that are in Azure, also on-premise environments or in other cloud environments. So the update management is going to keep in shape all the operating system. It doesn't matter where it lives. We have that possibility to improve and update all the systems. Again, it's important to make this update process because it is part of the security benefits that we have when we install these updates. We're going to patch and cover some vulnerabilities from our operating systems. So in the same way, well, this update management, you can see right here the following diagram is going to illustrate how to update, how to use this update management. This is going to assess and apply automatically security updates to all the connected Windows Server and Linux servers. The update management is going to be integrated with the Azure Monitor logs to store the update assessment and the update deployment result as a log data. All this from assigned Azure and non-Azure machines. All this is going to be able to allow us to collect this data. And well, in this case, this data, finally, we can move it to a log analytic workspace, so we can link this log analytics with an agent for Windows, or also we can establish this agent for Linux if it is required on the machine. So again, we're going to have a continuous feeding from our operating systems. This is a small table that shows us how does it work. In this case, the following table, it's a complete it summarizes the supported connected sources with update management. For example, you can see right here that the connector source, it could be Windows, Linux, or the Operations Manager Management Group. So all these trees are going to be supported, and this is going to be for log analytic information ingestion. This is going to be to report local or remote repositories. Again, we're going to feed this log analytics with a specific agent. And finally, well, in this case, for the Operation Manager Management Group, this is going to be in a certain way different. In this case, the update management is going to collect information about software updates, not only the operating system, and this is going to be fed from the agents and connected now for the management group. So we are going to establish a direct connection from the operation management agent to Azure Monitor logs. It is not going to be required, but we can establish this. And again, all the data that we ingest from this is going to be moved to a log analytic workspace. So we mentioned that we need to install endpoint protection. We can establish safe connections to our virtual machines by the use of RTP protocols, SSH protocols, Azure Bastion. We mentioned that it is important to keep in shape our operating system, but another way to protect our endpoint is through the use of disk encryption. So what is this disk encryption? Azure Disk Encryption is going to help us to protect our Windows and Linux infrastructure as a service disk or virtual, the hard disk drives or the solid state drives that are assigned directly to our virtual machines. So this disk encryption use the industry standard of BitLocker that we previously mentioned it in a brief way. So this BitLocker feature is going to be available for Windows, or in the other hand, we have the DMencrypt feature from Linux. Again, you can see that we have the possibility to protect both operating systems. And well, in this case, the solution is integrated with the Azure Key Vault. So this is going to help us to control and manage the disk encryption keys and also the secrets. This solution also is going to ensure that all the data on the virtual machine's disk are encrypted at rest in our Azure storage. In this case, disk encryption for Windows and for Linux virtual machines, this is going to be generally available in all the Azure public regions. And also, remember that we have Azure public regions and Azure government regions. We have the possibility to, well, it's going to be available for those regions. And also, we can establish Azure Premium Storage to secure and manage this disk encryption. Again, this is going to be an easier way to see it. There are several types of encryption available for us to manage this disk, including Azure Disk Encryption, Service-Side Encryption, and Encryption at Host. This is the difference, and this is what does it mean. SSA, ADE, SSE, and encryption at host. Again, this is going to be related with Azure Disk Encryption, Service-Side Encryption, and, well, encryption at host. This table shows us, well, if we have encryption at rest, if we are going to allow or manage the temp disk encryption of the caches, also if it is going to be available, how the data flows encrypted between the computer and the storage service. If we are going to be able to use custom keys, and if it is going to be available the use of Microsoft Defender for Cloud Disk Encryption and provide the appropriate status. In this case, we have this table, and you can see that the most healthy way to protect our disk is through the use of this Azure Disk Encryption or also encryption at host. So we're almost reaching the end of the session. It's just in a quick way, we are going to mention this Microsoft Defender for Endpoint allowed us to use different platforms. In this case, it's going to be available for Windows 7, 8, 10, and the newer version that is Windows 11. Also for Windows in their servers editions from the 2008 edition up to the latest edition, and also for another operating systems outside the Microsoft ones, for example, Android, iOS, Linux, Mac OS. So those well, let me take it from the top. Do you remember that Microsoft Defender for Endpoint is going to protect our Windows and Linux machines? Also, the AWS machines. There are some key security features that are included with Windows 10 and Windows Servers features. We have a tool called Credential Guard that is going to use virtualization-based security enhancement to isolate secrets so that only privileged system software can access to them. On the other hand, we have the Windows Defender application control. This is going to help us mitigate these types of threats by restricting the applications that users can run and the code that runs in the system core or also the kernel. So we are going to use policies in Windows Defender application control that also are going to block unsigned scripts and Windows PowerShell runs in constrained language mode. Right? So that's how Microsoft Defender for Endpoint is going to give us this additional protection. Just to close this session, well, we're going to finish mentioning that we can secure the Azure workloads with the Azure Security Benchmark. So the Azure Security Benchmark, this is going to be a collection of high impact security recommendations that we can choose to help secure services that we use in Azure. We have security controls and service baseline. For example, security controls are going to be these recommendations that are generally applicable across our Azure tenant and Azure services. And the service baseline, this applies the control to individual Azure services, all this to provide recommendations on that service security configuration. So for that, you can visit a related link that is going to be azure.microsoft.com, Microsoft Azure Foundation Security Benchmark, and you're going to know all the different, how does it work, and some recommendations and best practice that Azure Benchmark offer to us. For that, guys, well, let me open my camera for one last time. And again, this is how we are finishing our day number 2 with some problems. But again, thank you for your patience. Thank you for bearing with me. Again, it is such a pleasure to be here with you. I think it's a good moment to take our lunch break. Well, in my case, I'm going to verify my internet connection. But again, thank you so much for joining us. I hope to see you in the second part of this session. And remember, we're going to have we have an amazing team helping us with all the questions and comments that you have. So we're going to stay aware of your comments. In the second part of the session, you can leave the questions, the comments, and you can continue with your lab practices. Also, I'm going to display the list of the lab activities that we're going to follow in this day number 2. So again, thank you so much for joining us today. Have a great one and see you in the second part of the session. Take care, guys. Bye-bye.